Hi everyone, welcome to my YouTube channel. In the previous video, we have discussed the passing package of 50 questions with answers. So we'll continue with the remaining questions now. So the next question, what are strong acids? So what are strong acids? An acid in which breaking of ions is complete. So in strong acids, the ions will break completely. So that is said to be strong acid. So what are strong acids means? An acid in which breaking of ions is complete. So examples we know that well, hydrochloric acid, sulfuric acid, nitric acid. So these are all the strong acids where the ions will be completely broken. Next, what are weak acids? So weak acid means here the breaking of ions will be incomplete. So if the breaking of ions is complete is said to be strong acid. If the breaking of ions is incomplete is said to be weak acid. Example, benzoic acid, acetic acid, carbonic acid. So these are all the weak acids where the ions will be incompletely broken, means they cannot be completely broken. Okay. So the next question, write the chemical name, chemical formula and use of washing soda. By heating baking soda, when get washing soda. So here you have to see, look at the question. Usually there will be one question over this concept. So any chemical name, its formula and its uses can be given. Here washing soda is given. You have to write the chemical name, then chemical formula and uses. So by eating baking soda, we get washing soda. So how this washing soda is obtained means by eating the baking soda. Okay. So by heating baking soda, we get washing soda. So equation is like this. 2NaHCO3. NaHCO3 is sodium bicarbonate. Gives rise to Na2CO3 10H2O. This is sodium carbonate decahydrate. So what is the chemical name of this washing soda means? Sodium carbonate. Sodium carbonate is a chemical name. Chemical formula is Na2CO3 10H2O. Na2CO3 10H2O is chemical formula. And what are its uses means, as we know well, the washing soda generally used for the purpose of softening of hard water. So washing soda is used to soften the hard water, then used in the manufacture of chemical called borax. So this can also be asked for multiple question. Okay, so multiple choice questions, multiple type of questions they may ask. So like borax manufacture, which is the chemical used in the manufacture of borax, that is sodium carbonate. Sodium carbonate is also used in the manufacture of a chemical called borax. Then it is used in paper, glass and soap industries. So these are some of the uses. Okay, so we'll pass with the next question. Write the importance of pH in our everyday life or day-to-day life. So what is the importance of pH in our day-to-day life? So we'll see. Our body works within the pH 7 to 7.8. So our body maintains the neutral pH. Okay, so that is about 7 to 7.8. So we know that from 0 to 14 the pH scale will be there. So from 7 to 0, so from 0 to 6 it is acidic, 7 is neutral, again from 8 to 14 is base or basic. So our body works with the pH of 7 to 7.8. Then in tooth decay, when pH of our mouth is less than 5.5. So if the pH of mouth decreases like 5.5, then tooth starts decaying. So due to acidic nature, the acid produced, the tooth decays. Then rainwater pH less than 5.6 is termed as acid rain. If the rainwater's pH reduces, that is converted as acid rain. It means to say it becomes a acid rain. Then plant requires certain pH for their healthy growth. So in more acidic nature, the plants cannot survive. Even in more basic also they cannot survive. So they require certain pH for their healthy growth. Then self-defense by animals through chemical warfare. So some animals, by producing the acidic liquid or they are producing their sting, for example bee sting. So they produce some sort of acid which is acidic in nature, that is for their self defense. So the methanoic acid in the bee sting, which also acts as a self defense. So this is the importance of pH in our day to day life. So we'll move with the next part of the question. So the next question is, state right hand thumb rule or Maxwell corkscrew rule. So right hand thumb rule or Maxwell corkscrew rule. So we'll see what is the statement of this rule. Hold a current carrying straight conductor in your right hand. So in the right hand, you have to hold a current carrying a straight conductor, and the thumb indicates direction of current. So when you hold a current carrying a straight conductor in your right hand, so in the right hand, the thumb indicates the direction of current, forefinger indicates the wrapped around the current conductor indicates the direction of magnetic field. Okay, so when you hold a current carrying a straight conductor in your right hand, then the thumb indicates what? The direction of current, and the forefinger wrapped around the conductor, it is indicating the direction of magnetic field. So this is your statement of right hand thumb rule or Maxwell corkscrew rule. Okay, next, state Fleming's left hand rule. So what do the Fleming's left hand rule states? We'll see the statement. Hold your left hand such that the thumb, forefinger and middle finger are mutually perpendicular to each other, such that like this. You have to hold like this. Okay. So hold your left hand such that the thumb, forefinger and middle finger are mutually perpendicular to each other, such that the thumb indicates. What do the thumb indicates means? Thumb indicates the direction of force, forefinger indicates the direction of magnetic field, middle finger indicates the direction of current. So the Fleming's left hand rule states that when you hold a left hand such that the thumb, forefinger and middle finger are mutually perpendicular to each other, thumb indicating the direction of force, forefinger indicating the direction of magnetic field, middle finger indicating the direction of current. Next, what is fuse? How it works? We'll see what is fuse. A safety device which protects our electrical appliances from damage. So the fuse is a safety device which protects our electrical appliances. For example, in home or in house, the electric circuit will be protected by the fuse. So it is a safety device. So it protects our electrical appliances from damages. So it is made up of lead and tin. So they may ask the question for multiple choice here. So fuse is made up of lead and tin. So it is made up of lead and tin. It has low melting point. So it has low melting point and connected in series with the circuit. So with the circuit it is connected in series. When there is over or electric flow will be more or excess, then this lead or tin, this fuse melts because of low melting point and it breaks the circuit. Okay. So when excess current flows, the fuse wire in gets heated and melt and breaks the circuit and protects the appliances from damage. So the fuse is to protect the electrical appliances from damage. When there is excess of flow of current or more flow current through the circuit, then this fuse melts and it will break the circuit so that it protects the electrical appliances. Okay. Next, why copper and aluminium wire are used in transmission wire? So why copper and aluminium wire is used for transmission wire? So we'll see. Because it has conductivity and low resistivity. So because of its conductivity and low resistivity, copper and aluminium wires were used in transmission wires. Okay. Next, why heating coils are made of alloys rather than a pure metal? So heating coils generally they are made up of alloys. So why they don't use pure metal? Why? Because it has high resistivity. Alloys they have high resistivity, high melting point and does not oxidize easily at high temperature. So because of this nature, because of its high resistivity, high melting point and does not oxidize easily at high temperature. The heating coils are made up of alloys rather than the pure metal. Okay, so we'll see the next question. Write the differences between biodegradable and non-biodegradable substances. So biodegradable substances means it is converted into simple substances by biological process. So by any biological process, they can be easily converted into simple substance, that is biodegradable. If they are not able to convert into simple substance by biological process, that is non-biodegradable. Then biodegradable remains less time in environment as they easily decompose or they undergo decomposition. They leave less time in environment. But non-biodegradable, as they don't decompose, they remains a long time in environment. Biodegradable, they do not cause pollution or they are very less in pollution. But non-biodegradables, they cause more pollution. So we know the examples like vegetable peels, fruit peels, cow dung, animal dung, they are all biodegradable. Paper. But non-biodegradable, the plastic, rubber, glass, they are all non-biodegradables. Next question. Name the following. So you have to name. These questions may be given for 1 mark. So we'll see one by one. Name the following. Liquid metal. So which is a liquid metal? So liquid metal means it is mercury. So mercury is a liquid metal. Liquid non-metal means bromine. So bromine is a liquid non-metal. Then soft metal. So soft metals are sodium, potassium, lithium. Then poor conductor of heat. So which are the poor conductor of heat means mercury and lead are the poor conductor of heat. Then a metal having low melting point, gallium and cesium. So gallium and cesium are a metal with low melting point. Hard non-metal having high melting and boiling point. So this is a hard non-metal, but it has it has high melting point and boiling point. So that is diamond. So diamond is a non-metal. It has high melting point and boiling point. Then a non-metal which is good conductor of electricity. So graphite is a non-metal which is a good conductor of electricity. Then lustrous non-metal. So lustrous non-metal is iodine. So iodine is a lustrous non-metal. Then metal that reacts only with the steam but not with hot or cold water. So this metal reacts only with the steam but not either with hot or cold water. Iron, aluminium, zinc. So iron, aluminium, zinc, they do not react with hot or cold water except steam. So the next one, so we'll see the next. A metal that reacts with hot water only, magnesium. So magnesium is the metal which reacts with only hot water. Then most malleable and ductile metal. So most malleable and ductile metal, it is gold. So gold is a most malleable and ductile metal. Next, give reasons. Here are some reasons. You have to give the reasons for these questions. Ionic compounds are solid and hard. So why ionic compounds are solid and hard means because of strong intermolecular force. So ionic compounds, they have strong intermolecular force. So because of that strong intermolecular force, they are solid and hard in nature. Next, ionic compounds have high melting and boiling point. So ionic compounds, they have high melting and boiling point. Why means because more energy is required. So more energy is required to break the strong intermolecular force. See here. So ionic compounds, they have high melting and boiling point. Why means because they require more energy to break the strong intermolecular force. Okay. So they require more intermolecular, more energy to break this intermolecular force. So that's why they have high melting and boiling point. So the next question, ionic compounds do not conduct electricity at solid state. So as they do not move, means the ions are not able to move in solid state, ionic compounds cannot conduct electricity in solid state. But when they are molten, means when they are under the liquid state, ionic compounds conduct electricity. That's why ionic compounds conduct electricity at molten state. Why? Because ions can move freely in the molten state rather than the solid state. Okay, so these are the give reason questions. Next, we'll pass on to the next question, the properties of ionic compounds. What are ionic compounds? Write their properties. The compounds formed due to the transfer of electrons from metals to non-metal. So how these ionic compounds are formed means by transfer of electrons from metals to non-metal. They are called as ionic compounds. So the compounds formed due to the transfer of electrons from metals to non-metal is called ionic compounds. Their properties are ionic compounds are solid and hard. Ionic compounds have high melting and boiling point. Ionic compounds do not conduct electricity at solid state. Ionic compounds conduct electricity at molten state. So these are the properties of ionic compounds. Next, why do magnetic field lines intersect each other? So why do the magnetic field lines intersect each other? Because at the point of intersection, there will be two directions which is not possible. So that's why the point of intersection where the two directions is not possible, the magnetic field lines intersect each other. Okay. Next, what are electromagnet? A solenoid with a soft iron piece placed inside it. So what are electromagnet means? A solenoid with a soft iron piece placed inside it is nothing but electromagnet. Next, what is overloading? What are the causes for overloading? So a situation where the current flows more than the required. We know overloading means itself is more than the requirement. A situation in which current flows more than the required is nothing but overloading. So why it is caused? What are the causes for this overloading means? Due to many appliances are connected to a single socket or a single circuit. So when you connect more appliances to the single socket, then it will be overload. Due to the sudden hike in voltage. So if the voltage is hike all of a sudden, that causes overloading. And even when the light comes in contact with the neutral wire. So that is also causes overloading. The next question, what is short circuit? What is the causes for short circuit? A situation in which current increases heavily and resistance becomes almost zero. So if all of a sudden current increases and resistance becomes zero, then that causes short circuit. That is due to overloading. Okay. So what is the cause for short circuit means overloading. So means the current flows more than the required all of a sudden. So then the resistance becomes zero. So then there will be short circuit. Okay. Give examples for natural indicators. So examples for natural indicators, litmus paper, turmeric, red cabbage leaf extract, so the flower of hydrangea plant. So these are all some natural indicators. So then artificial indicators, methyl orange, phenolphthalein, they are the artificial indicators. Olfactory indicators, onion, clove oil, vanilla essence. So these are the olfactory indicators. So we'll go with the next question. Name the acid present in the following. So we'll see which are the acids present in the given. Tomato, oxalic acid is present in tomato. Vinegar, acetic acid is present in vinegar. Tamarind, tartaric acid is present in tamarind. So the next question, we'll move with the next question. So that is lemon. So which acid is present in the lemon? That is citric acid. Citric acid in lemon. Lactic acid in curd, methanoic acid or formic acid in ant sting. So ant sting, bee sting, so they all contains either methanoic acid or formic acid you can say. Okay, so these are some of the acids present in the following. Next, why acidic, basic and salty solution conduct electricity? So why do the acidic, basic and salty solutions conduct electricity? Why? Because due to the breaking and movements of ions. So in acidic, basic, salty solution, the ions will break and move. So that's why due to the movement of ions, they conduct electricity. Next, does glucose and alcohol conduct electricity? No. So they do not conduct electricity because they does not contain any ions. So where there is ions, there is a movement of ions. causes electricity. If no ions are there, they do not conduct electricity. So glucose and alcohol does not conduct electricity. Okay, next. What is pH range? So the pH range, the scale, you know that from 0 to 14. So 0 to 14 it is a pH scale. Then what are antacids? So antacids means a medication to neutralize acids present in stomach. It is antacids. So when there is excess of acidic in the stomach, to reduce, to neutralize that acid, the medications what you take, it is nothing but antacid. Example like baking soda, milk of magnesia. So this acts as an antacids. Okay, next question. Give reasons tap water conduct electricity but not distilled water. So why do the tap water conduct electricity but no distilled water? Means tap water contains more ions than the distilled water. So as the tap water contains ions, they conduct electricity, but distilled water do not conduct electricity. Next, why POP is kept in moisture proof container? So plaster of Paris, POP is plaster of Paris. Why it is kept in moisture proof container? Means when it catches moisture, when it come in contact with the moisture, it becomes a hard mass called gypsum. To avoid to become the hard mass gypsum, POP is stored in waterproof container or moist proof container. Okay, so these are the questions. The remaining 25, so far we have discussed 25 questions in this video. Okay, so the remaining 25 questions we'll discuss in the next video. Thank you.